So this is the first video of the Polymath machine, this homemade analog computer working. You can see the backlit dials here. A little bit too bright. Let's see. You can see the numbers there. So this is the initial derivative condition, initial position, coefficient of y prime t, the coefficient of yt. So y double prime is going to equal plus and minus c1 y prime. Well, this sets c1, sine of c1, c2 sine c2's coefficient, c1 is here, c2 is there. So it solves a system of this, and here's the solution. It's solving this is without the damping term, so you can get all sorts of trajectories here. So we're going to move the initial condition up, and you can see the moment you turn the dial it gives the solution. Move it down, okay, move the initial velocity up, move initial velocity down, and you can really mess with these terms. So for example, let's turn back on a damping term. That's opposite there. That's the damping effect. So you can model a suspension system doing this. So if you were to increase or decrease the solution term, alters the frequency. Increase or decrease the y prime term, alters the damping. So that's heavily damped, that's underdamped, and that's undamped. So this one's all the way off. This knob here sets the interval of solution, so it solves it faster and faster, little time intervals. The one in this period in between is resetting the initial conditions. You can pretty much get a wide variety of behaviors. If we flip the term on the damping term, or in other words, flip the sign of C1, so it solves an equation here where y prime is 0 is set by here, and y 0 is set by this one. So you can get some interesting solutions. So I turn that one down, turn to get a tinier waveform starting out. We flip the sign of a damping term, and so you can get this. It's an exponentiating sine. Oop. If we damp it, you remove the damping outright, exponentiating. So an analog computer allows you to play with these functions. But note that the C2, for an oscillation to exist, C2 must be negative. If you put it positive, it just gives you an exponential curve there. Some nonlinear behavior. So like this right here would be critically damped. That's overdamped, overdamped, overdamped. Underdamped, undamped. Anyways, I thought this would be interesting to show off this machine. It's going to have a back put on. So you have your second order problem set here. Might as well show you the back. It's a lot of electronics back here. The dial lights, the integrator boards, those two, amplifier, timer board, the strips that hold it all together. So you can see it from this perspective. These took forever to wire. Anyways, I figured I'd make this video showing this thing off. Hopefully I'll have more later. hope that was interesting. I might expand this to do higher order problems, I might not. But it's a laptop or portable analog computer, so it's going to have this oscillograph on the board here, so you can carry it around. That was the idea. Anyways, I wanted to show off my prototype laptop analog computer, and hope you have a good day, and hope this video was enjoyable.